Right now, as your code runs, something extraordinary is happening beneath the surface. Memory is being born and abandoned at millions of operations per second. And eventually, inevitably, something has to clean it up. A typical Java application doesn't just allocate memory, it devours it. Hundreds of megabytes every single second. Without intervention, every program would consume all available RAM and collapse. The garbage collector is the only thing standing between your application and oblivion. Every object your program creates lives on the heap, a vast, unstructured expanse of memory managed entirely by the runtime. As functions return and variables go out of scope, those objects don't vanish. They remain orphaned, consuming space that can never be reclaimed without the collector's intervention. The collector's first task: determine what is alive. Not by checking timestamps, not by counting references, by tracing every connection from a set of root objects, the stack, the globals, following every pointer until every reachable object has been found. Everything else is already dead. Traverse the entire graph of live objects and paint them. Sweep, scan every cell in the heap, and reclaim anything that wasn't painted. Simple in theory, brutally expensive in practice. Every object in memory must be visited. Every dead object must be erased. The cost scales directly with the size of your heap. Here is the moment that changes everything. To safely mark live objects, the collector must ensure no new references appear or disappear while it works. So, it broadcasts a signal, and every application thread in the entire process comes to a complete, total, utter stop. The world is paused. Time itself, from your application's perspective, ceases to exist. Legacy garbage collectors could freeze your application for 10 full seconds. 10 seconds where your web server answered nothing, your trading system executed nothing, your game froze completely. These weren't bugs. They were the price of keeping memory clean. Modern collectors have driven that number down to single-digit milliseconds, but the price is never zero. Through decades of observation, engineers discover something remarkable. Most objects die young. Variables created in a function call are gone before you blink. So why scan the entire heap every time? The generational hypothesis split memory into two worlds. A young generation collected constantly, and an old generation collected rarely. What if the collector didn't need to stop the world at all? Try color marking runs concurrently with your application. White means unvisited. Gray means discovered but not fully traced. Black means safe, all references explored. The collector advances a wave of gray through the graph while your threads keep running alongside it. An engineering marvel hiding in plain sight. Not all garbage collectors are created equal. Serial GC, single-threaded, stop the world, simple but brutal. CMS, concurrent mark sweep, low latency but fragmentation prone. G1GC, region-based, predictable pause targets. ZGC and Shenandoah, the new guard with pauses measured in fractions of a millisecond. ZGC, Shenandoah, G1GC. These aren't just better garbage collectors. They are the culmination of 40 years of computer science research. ZGC achieves sub-millisecond pauses on terabyte heaps using colored pointers. Shenandoah relocates objects concurrently without stopping the world. These are engineering achievements on the scale of compilers and operating systems. Every garbage collector walks a tightrope between three forces: throughput, latency, and memory footprint. Optimize for throughput and your pauses grow longer. Minimize latency and you sacrifice raw performance. Add more memory and everything gets faster until the machine runs out. There is no perfect garbage collector, only the right one for your workload. Every millisecond your application freezes, users leave, revenue evaporates, SLAs crumble. The garbage collector is not an implementation detail. It is an architectural decision with consequences that ripple through your entire system. Choose your collector, tune it, measure it. The cost is always there. The only question is whether you control it. The garbage collector is one of the most consequential pieces of software ever written, invisible, essential, and profoundly misunderstood. The next time your application pauses, just for a fraction of a second, remember, the world stopped, and then it started again.